Hello, my name is Dr. Paul Houle, and I'm going to be your guide in this program, as you can see here, titled Radon Measurements in Schools, Best Practices. This is a primer. It will not cover every nuance and option that's available in doing this testing, but it's going to give you an excellent place to start to see what's involved with doing a radon testing program in schools. It's brought to you by two agencies, the Pennsylvania Department of Environmental Protection, which has a very proficient radon division, and the American Lung Association, who has provided a grant for the production of this program. As for me, I've been a physics professor for 35 years, retired a few years ago. I've been involved with the radon issue since the mid-'80s, and have received numerous grants from both private and governmental agencies. I have been the former president of the National Radon Safety Board, and I have provided numerous training programs for both the National Radon Safety Board and the American Association of Radon Scientists and Technologists, as well as for many states as well. This program is based upon, as you see here, EPA's document titled Radon Measurements in Schools, the Revised Edition. The revision isn't very big, but make sure that should you get this document, it's the Revised Edition. One way to get it is just go to epa.gov and in the search window type the title of that document and it'll pop up and you can print it out for your convenience. Or you can simply copy this URL that I've got right here and that will take you directly to the document. Now, because we're not going to include every single detail of how a testing program for schools needs to operate, we're going to include 3 additional shorter programs, the URLs for which will be given in the very last slide of this video, and they will cover health, how many detectors work, and the issue of quality assurance, which is incredibly important. You can also find additional information by going to the National Radon Safety Board's agency, the nrsb.org, go to their continuing ed section and identify courses that might be useful to you dealing with radon measurements in schools. You can also go to the American Association of Radon Scientists and Technologists and take a look at what they have for radon training in schools. Some of these programs can be done at home as well. I need to alert you, though, to the fact that in Pennsylvania, the guiding protocol is the one that was titled a bit earlier, Radon Measurements in Schools, Revised Edition. Furthermore, the American Lung Association has, in past years, provided free training for school districts who are interested in doing a radon testing program. And in fact, the American Lung Association has also provided free test kits for schools in the past years. That might be a source valuable to you. Let me begin by EPA's map for Pennsylvania. And you'll notice here there's some reds, there's some oranges, and there's just one, Philadelphia, that's in yellow. These are separated out by counties, and you can probably find your county in here. Fundamentally, though, the point of this particular slide is to show you that the red areas are those areas where the radon concentrations, at least in homes, are expected to be greater than or equal to 4, the average values. In the orange areas, the average values of homes to be tested or have been tested is expected to be greater than or equal to 2 up to 4. And then the yellow, which is the only one here in Philadelphia, is the expected values for the average of radon concentration measurements in homes is expected to be less than 2. But I want to point out to you, very important, that you recognize that while the average value in, say, an Orange County here is going to lie between 2 and 4, or at least that's what's expected to occur, That doesn't mean that every home is going to have a radon concentration between 2 and 4. Some of them are going to be down around 0.5 and 1. Others will be around 10 and 15. And I'll show you some specific data in that in just a second. But I want you to recognize that the only way to know if a building has a radon problem is to test for it. Now, it has a radon problem if the concentration comes out to be greater than or equal to 4. That's called the action level in the United States. And if it comes out to greater than or equal to 4, the EPA and the Pennsylvania DEP strongly recommend that the radon concentration be mitigated to values to less than 4. Now let's discuss why we should be concerned about the radon problem. And I've put a few bullets up here that you can see. The first of which reads, there are 21,000 estimated deaths per year due to radon. That's an EPA estimate, and that number has changed over the years, but it remains a representative number. There is widespread contamination in schools at the national level. That's what's expected. And that doesn't mean that every school building is going to have a radon problem. What it means is that there is no school district that can come along and say legitimately that we will not have any radon in any of our buildings. That just would not be correct in saying that. 20% of all schools will have at least one room with a concentration greater than or equal to 4, and that's on a national level. Now in Pennsylvania, as you'll see in the very next slide, we expect that 20% to actually be higher than that. Now it doesn't mean that when you test a building that you expect the entire building to be filled with radon. That's not what we see. What we typically see is that if there is radon, it'll be a few rooms, usually abutting one another, that have a radon problem, and the rest of the building is relatively clear of radon. And Pennsylvania is certainly one of the most problematic states in the Union to have a radon problem. In fact, it was in Pennsylvania where we first became aware that the radon health problem could be a significant issue in a typical home. Next, let's look at some data that we have from the Pennsylvania DEP. And in particular, you can see the data here is listed. 40% of the test results in Pennsylvania have come in with concentrations greater than or equal to 4. That is above the action level. And this 40% of the test results is significantly higher than the percentage of test results nationwide that are coming in greater than or equal to 4. So we are expecting that the percentage of schools that have at least one room with a problem is going to be higher than that 20% we saw a moment ago. 23% of the test results are between 4 and 10, 5% between 20 and 50, and about 0.5% of test results greater than 100. And don't let that 0.44% fool you that it's a small percentage, because there's significantly more than 1 million results that the Pennsylvania DPE has. And so that 0.44% represents more than 5,000 tests that have come in with concentrations greater than 100. Even the county where Philadelphia is located, which, if you remember that EPA map just moments ago, showed it as yellow, even that area has had homes in it with radon concentrations greater than 100. So I'm going to say again that the only way you're going to tell if a home, a building, or a school has a radon problem is, in fact, to test for it. And I should also like to point out that in Pennsylvania in the last few years, a number of homes have been found with radon concentrations in the many thousands. Now let me say a few words about who can test. And I've separated this out into two categories. You can see here certified testers in Pennsylvania and the school staff. Each can do it. Now, the certified testers, they've satisfied certain requirements in Pennsylvania and demonstrated their ability to do radon testing to the Pennsylvania DEP, and the DEP has certified them as being able to do radon testing. Now you can call a radon tester and tell them, well, I want to test this building, and let him work out all the details of it. But I can tell you this, he's going to need some help from the school staff in any case, identify which rooms to test and when the testing can occur. So the case of using certified testers still requires a little bit of school staff effort in that regard. The cost will be higher than if you use the school staff yourself. Fewer details for the school staff, certainly. And you'll get some professional liability protection in the process. Now, you can do it with school staff as long as they have proper training. And this 1-hour video is not enough to call it proper training. It is, however, an excellent overview of what the testing program consists of and what the school staff will have to do. There's a document titled Radon Measurements in Schools Revised Edition that the EPA publishes, and we give you the URL for it somewhere further down in this video so you can download it and print it out. And that's the document that the school staff, whoever's going to do the radon testing within the school staff, needs to master. So you'll want a little bit more training than this video alone is going to provide. And I can tell you that the American Lung Association has in preceding years given that training for free in your own school district. And so you may want to contact the American Lung Association, and we have references for that in this program as well, and see when they might do it in your area next. And in a number of cases, they've even provided free test kits to school districts wanting to test for radon. And you can see some of the benefits here. Now, I don't mean to suggest that you can either use your school staff or do the certified testers separately and just by themselves. You can combine the two. You could decide, for example, or your administrator could decide, we're going to use the school staff to do the testing. And but what we're going to do is, after the testing is all planned out, and there's a modest amount of planning that has to occur, but once the planning has been done, then we'll have a certified individual come in and review the planning to make sure we're on the right path. They may also suggest that, well, let's have a certified tester come in at the end when we have all the results and review the results with us. The point I want to make is there may be a place where the school staff is doing the testing. There may be a place for a certified tester to take part in it as well. Now, fundamentally, it's a detective mystery. We don't know which schools are going to have a radon problem. And in fact, we don't know which rooms within the school is going to have a radon problem. Only you, the person doing the testing, is going to discover that. Just you. That's it. Of course, you're going to pass that information along. And so your job will be to hunt down and identify which rooms have a radon problem. That is a concentration greater than or equal to 4. Now, in order to get a good handle on how the testing protocol should be run, it's important to know, how does the gas get into the building? First, recognize that it is a soil gas. You can look anywhere in the ground and you will find radon gas, as you can find most any other soil gas. Some parts of the ground will have more than others, but I have never seen a piece of ground tested where there wasn't some radon in it. That by itself, of course, is not enough to tell you whether or not you're going to get radon in the building. There's a lot about the building that has an impact on whether or not the radon is going to get in. So recognize this. It's a soil gas. It's generated in the ground. It's a radioactive gas, and that's part of the problem. The gas percolates up through the ground, and if you have a building in place there, the gas has the opportunity to get into the building. And what routes will it take are given here in this drawing and this table. You'll notice I've identified there are cracks in the floors. There may be expansion joints. There'll be conduit penetrations into the building. Many of you are already aware of all of these kinds of ways for the radon to get in. And in fact, here in the drawing, you'll notice there's even a little water tank to indicate that there's the potential for radon to get into the building via the water. Now, that's a fairly distant second from the gas percolating up and getting into the building directly as radon and air. And so we won't go into much detail on that particular issue. But you can see here I've listed cracks in solid floors, construction joints, etc., HVAC operations. The reason the gas gets into the building is because the pressure in the ground, the gas pressure in the ground, is actually higher than the pressure in the building. So it's actually driven into the building. I'm going to underline this with a couple of slides a little bit later. But what I would like you to get out of this slide is that it is a soil gas, and it's going to percolate, or can percolate, through the ground and into your building. The lower the pressure is in your building, the easier it is for it to be driven into the building. Now, how much is too much? I actually alluded to that in the very beginning, that the action level in the U.S. is 4. Now, the unit is picocurie per liter, which is a clumsy unit. I don't personally like it, but it's what we use here in the U.S. And I will not be saying that unit, but I will be talking about radon concentrations of 4s, 10s, 50s, and 1,000. And I will be meaning picocuries per liter. The DEP recommends strongly that if you have 4 or more, that you should mitigate that problem. And you can consider action if it's between 2 and 4, because mitigation systems can often get the radon concentrations down below 2. Now, the type of detectors that you're going to use, that you're most likely going to use, are charcoal detectors. Now, there are other kinds of detectors available to you for your use, and we cover those to some degree in the extra video, which is called, which has in its title the word detectors, and you'll see it in the URLs on the last slide. But I want to show you the charcoal devices that you will probably use. There's the kind here that are charcoal cans, and you can't hear this, but the charcoal is in there. And when you buy them, they look like this. They may come in a bag with some documentation, etc. But to activate it, all you have to do is pull this off, and you'll notice there's a hole in the can, and deploy the can. Now, I usually put the sealing label on the bottom so I can find it again later, and just deploy it in whatever room you want in some appropriate place. So we'll talk about locations, and we'll talk about which rooms too. But that's it. Now it's deployed and it's working. What it does is radon, along with all the other gases in the air, diffuse through the lid, through that hole in the lid, and gets into the can, gets absorbed by the charcoal. Now, it's radioactive gas. Now, don't be afraid of that. You're not going to collect enough in here to make any difference at all. Perfectly safe. But you're going to collect that radioactive gas in here. And then once the deployment is finished, you'll put the sealant on top. You'll fill out some paperwork, which we will also get to, and you return it to the lab. The lab will take it, and they will take a look at the radioactive pieces that are given off by the radon gas. That is, the radon gas is radioactive, and that by that I mean that it breaks up. The gas atoms break up. And when they break up, they give off these little bullets. Some are called alphas, some are betas, some are gammas. But the ones that will be looked at in this can are gamma rays. And they will count up the number of gamma rays, and they will, from that, determine what the radon concentration in the can must have been, and from that, what the radon concentration in the room must have been during the deployment period. It gives you one value, an average value. One of the concerns about all the charcoal devices is that once you seal it up, the radon's in here and it's decaying. And if you wait a couple of weeks or even a week, then you'll be down to 25% of the amount of radon that was in here. Now, labs can correct for the amount of time it takes to get this detector back to the lab. However, if you wait too long to get it back to the lab, then when it gets there, the amount of radon in the can will be so small that the lab won't be able to confidently detect the value, and they will tell you that we can't come up with a good value for this. So what's important here, and what I'm leading to, is that if you're using a charcoal device, and many of you will, you should, once you seal it up, get it back to the lab promptly. In other words, you'll collect them all on a given day. There might be 50 or 100 or more, and send them back to the lab the same day. Another kind of device that you can use, it's another charcoal device, and this is a fairly common device. You can hear the charcoal in it, and I think you can even see the charcoal in this plastic tray. And this works the same way as the charcoal can. You don't peel anything off of this. This is the way it gets deployed. It comes in a sealed bag, and you take it out of the sealed bag, and you simply deploy it just as I'm showing you here. This is the side that needs to face the atmosphere in the room. You don't want to put it upside down. You want to put it right side up and put it in the room. You leave it out for the appropriate number of days, and you'll note here on the slide that I know 2, 3, 4, and 5 days. 5 days is probably the best because it'll cover the entire week. So from Monday morning to late Friday afternoon, that would be probably the ideal deployment. But be careful. Wherever you get the kit, make sure you identify how many days that detector can be deployed. In some cases, 4 days is the maximum. So if you deploy it for 5, the lab may well tell you they cannot analyze that it was deployed for too long. But those are deployed for, as you see, 2, 3, 4, 5 days, and those are called short-term detectors. They give you an average value over the time they were deployed, and that's a very good average value. However, you may want to deploy for a longer period, and in that case, you cannot use charcoal detectors. You'll need to use something different. And the detectors that are available for that purpose are the alpha track detectors, and I have one right here. I'm going to show you how it works. I'll show you a little bit about it anyway. And so here's the detector, and it comes in a plastic bag sealed up. And there's a little tag on it that says void if opened. So you don't want to open it. You don't want to do anything with it. But this does not have any charcoal in it. What it has is a little plastic strip, which I'm going to show you right now. It has this little plastic strip. And the radon gets into the volume of this alpha track detector, even when it's sealed up. It gets in through the tiny little crack, this little seam here. And then when the radon decays in here, one of those little projectiles that it gives off happens to be called the alpha particle. If that alpha particle strikes that plastic, it actually scratches the plastic. And then when you return this to the lab treats the plastic, and then it can count up the number of scratches. And from that, it can determine what the radon must have been in the room during the deployment period. Now, typically, these can be used for long-term measurements, 90 days or more for their measurements. As I said, there are lots of other detector types that can be used, and we cover them in the video that's referenced at the end on detectors. And you can take a look at that maybe when you're done with this program if you want to see how the other detectors work. But really, more than 90% of all the schools that have been doing testing have done them with charcoal devices. We're going to now look at the protocols. That is, how do you deploy them? Which rooms do you test? We're going to look over all of the salient details. Again, you'll need to become a master of that document prior to starting a testing program. But our review of them right here is going to give you very much the majority of what you need to know. You have really two choices in doing your testing. You can do short-term measurements where you'll be using charcoal detectors, or you can use long-term measurements where you will very likely be using alpha track detectors. So those are the two choices you have. Now, if you're using short-term measurements, that is, you're going to be deploying a charcoal detector, you're going to do an initial measurement, and then for those rooms that show up as having a potential problem, that is a value greater than 4, you're going to do a follow-up measurement in just those rooms. So watch the details here. Initially, again, if you're using short-term measurements, initially you're going to deploy a detector in all frequently occupied rooms in contact with the ground. Now, this is pretty specific, but I noted an asterisk here because there are a few nuanced exceptions to this, which you will find in one of the videos towards the end, and you'll also find it in the next slide or two. You're to test all rooms simultaneously. So if you've identified 100 rooms that you're going to test, that doesn't mean you need 100 people to put out all the detectors at the very same moment. Rather, you're going to put out detector number 1, and then number 2, and then number 3, and it might take you all morning to do this, and by that we mean simultaneously. It's best to do it during the school year, and preferably during the heating season. During the school year requirement is an attempt to get a measure of the health risk. That is, what's the risk to people while they're in the building? And during the heating season will give us the best opportunity to establish what are called closed conditions. That is, where the windows and doors are not opened any more than is absolutely necessary. And you're most likely to get those conditions met during the heating season. Now, let's assume that you've deployed 100 detectors, you've sent them to the lab, you've gotten the results back, and 4 or 5 rooms have come up with concentrations greater than 4, greater than or equal to 4. That's typically what we see. If a building's going to have a problem, it is not common to see the entire building with lots of radon. It's really much more common that 4 or 5 rooms, typically all connected to one another or all next to one another, have the radon problem. So let's make that assumption for this video, that you deployed 100 detectors. Let's say 5 of them came back with concentrations greater than 4. You're going to now do a second measurement on those 5 rooms that came in with concentrations greater than or equal to 4. And the reason is we want a second value to try to identify and confirm that those values are in fact above 4 or equal to 4. So here it is here. You're going to do a follow-up test in every room with a short-term initial test result of 4 or more. You're going to put the detectors in the same location and under the same conditions as the initial measurement, and you're going to deploy them as before simultaneously. Now, this means that if your initial 100 went out at Monday at 7 a.m. or Monday morning, the follow-up should go up at the same time and be deployed for the same period. Notice here that I put an asterisk. The follow-up can be between 2 and 90 days. Now, when you're using the charcoal devices, you're going to be putting them out for 3, 4, 5 days. You're probably not going to do much more than that with the charcoal detectors. I put an asterisk here because there is another option for you to do a follow-up with a long-term measurement which is in the protocol, but I am not going to include in this program. So in this program, what I'm talking about is you do the first 100 detectors, all short-term measurements, and those that produce a radon concentration greater than or equal to 4, you're going to retest those rooms. That's a good scientific procedure. We don't always believe what the first value is. We go back and we confirm that value. And then you're going to take the average of the two measurements. So let's say one of the rooms comes in with a value of 5. And then you do a follow-up in that room, and it comes back with a value of 7, let's say. Well, the average of those two is 6. And you ask yourself the question, is that average greater than or equal to 4? And if it is, then that's a room that you need to seriously consider mitigating. So it's the average of those two values that you're going to use to determine whether or not a mitigation is going to occur. And that's if you're doing a short-term measurement to start with, and then a follow-up that's also short-term. You have the opportunity, this is one of the options given in the EPA protocols, to do the first measurement as a long-term measurement, that is greater than 90 days. And for that, of course, you'll be using the alpha tracks. And in that case, if you're deploying 100 alpha tracks, you're going to measure all the rooms frequently occupied in ground contact. And when the 100 come back, and you'll have all these values, if any of them come out greater than or equal to 4, you don't do a follow-up measurement. You just base your mitigation decision on this one detector value. And you see here, all frequently occupied rooms in contact with ground, and of course there are a few nuances there. All rooms to be tested simultaneously during the school year, preferably during the heating season. There are one or two other ways to deploy detectors, which I'm not going to cover because what I'm covering here pretty much is the way more than 90% of all the schools have proceeded. Now I want to take a look at the 3 different structures of rooms. They are slab on grade, as you see here. There'll also be those on a crawl space and those with a basement. And we're going to look at those 3 cases and which rooms do we test. I want to expand what we've just said about the frequently occupied rooms in contact with the ground. And you see it here, slab on grade, exactly that. Measure only frequently occupied rooms in contact with the ground, and those would include classrooms, offices, labs, cafeterias. You can see it here. You don't have to do closets, storage rooms, and the other items here because they're not considered frequently occupied. Now, why are we doing all of these rooms in contact with the ground? For that, I want you to remember how the radon gets into the building. It's a soil gas. It comes up from the ground and goes into the building. Well, the first place it's going to be is in the first floor. If you have an open plan or pod design, you can see here, you can read it for yourself, of course, that if there are movable walls that can physically separate one section from another section, then you're to put a detector in each section. If it's just one big open space, then you put one detector for every 2,000 square feet. So let's say you have a 5,000 square foot space with lots of activities going on and no real walls in that space, then you would need to put in, 5,000 square feet. You need one for every 2,000 square feet, so you'd need 3. Now, that doesn't mean you put all 3 together in one space. You would move them around so you're sensing all of the different spaces. Not actually move them around, but locate them in 3 spaces that are separated from one another so that the sample samples the entire space. Now let's take a look at a crawl space. If classrooms are above an enclosed crawl space, you're to measure the rooms directly above the crawl space. So here's the room above the crawl space. Notice this room is not in contact with the ground, but the crawl space is. So what can happen is the gas can come up from the ground into the crawl space and then percolate up through the floor and into the classroom. This is why we test these rooms. We don't test the crawl space because those are not frequently occupied, but we will test this room because it's frequently occupied above a space that may have a lot of radon in it. Now, in a basement design, this is similar to the crawl space. First, note that the drawing here has the first floor not in contact with the ground. So, do we measure these rooms if they're not in contact with the ground? Well, if this room was measured, we would not measure this room. But let's suppose this room is not frequently occupied. It's clearly in contact with the ground. But let's suppose it's not frequently occupied, so it doesn't meet the condition of being both frequently occupied and in contact with the ground. It's more like a crawl space, because if we don't test this because it's not frequently occupied, then it could be filling with radon, and that could be percolating into this room, and so we would test this room, even though this room is not in contact with the ground. We would test it if it's frequently occupied. Now, where in the rooms do you put your detectors? You can see here that you don't place detectors near drafts resulting from heating, ventilating vents, etc., etc. You don't put it near doors and windows. And the reason for these is a lot of these detectors are sensitive to breezes passing over them. They're sensitive to temperature. If you raise the temperature of the detector very much, its efficiency at collecting radon actually goes down. And so you want to keep it away from fans, doors, windows, as you see written here, to avoid all these effects of draft and temperatures, higher temperatures in these things. You place them where they are least likely to be disturbed or covered up. So what I often do is when I enter a room to deploy a detector, I stop in the doorway and I look around. And I look at the vents in the ceilings and I say, well, there's a vent there, so I don't want to put a detector here because it'll be in the path of the air coming out of that vent. I can look at exterior walls. We're not going to place them near exterior walls because exterior walls can get ghost drafts. And I can eliminate a lot of spaces right off the bat. And in a minute or two, unless I can identify where I'm going to put the detector. Sometimes you can put it on the teacher's desk. Now, if you can ask the teacher, hey, where's a good place to put this detector that it won't be tampered with? She or he might give you a good idea of where that detector should go. So you want to put it where it won't be tampered with. And of course, you don't want to put it in direct sunlight or in areas of high humidity, because high humidity can impact these detectors as well, which is typically why we don't do restrooms. Because the humidity tends to be a little bit higher in those spaces. Furthermore, now we have some very specific information here. We want the detectors at least 20 inches from the floor. The reason is we would like the detectors to be sampling the air that we're breathing. That is clearly the most important sampling area. And that is not on the floor. That is going to be above the floor somehow. So the minimum height above the floor is 20 inches. You want to keep it 4 inches from other objects. That's so the detector won't be impeded by the natural ventilating flow of the air in the room, and the detector will sample the air as the air goes past. Keep it from exterior walls of the building to avoid ghost drafts, and 3 feet from windows and 1 foot from exterior walls. So now we have some very specific information here as to where you can place these detectors. Place 1 detector for every 2,000 square feet. We talked about that. And then don't disturb the test device at any time during the test. We'd like the detector left alone. When do you test? Well, you want to test under closed conditions as is specified here. And I mentioned that before. The reason for the closed conditions is we don't want the radon in the air to be diluted by outside air. So if you make a measurement in the heat of the summer and your windows in a classroom can be opened, it's likely that they will be opened, and then you won't get a representative value for the radon concentration in the room because the air will have been diluted by the outside air. And when you're doing short-term measurements, you're to establish closed house conditions, or closed building conditions rather, for 12 hours prior to the deployment of the detector. And so I note here, initiate testing after a weekend. Now this is really pretty easy. If you go to work at 6 or 7 o'clock in the morning and into a school, then it's been closed since 6 or 7 o'clock Sunday night, chances are. So the closed building conditions have already been established. And so Monday morning is a great time to make a detector deployment. So that'd be the good time to put out your 100 detectors. Of course, during the colder months, again, that's to help maintain closed house conditions and run your HVAC system normally. Don't make any changes to the HVAC system. Run it normally. A few cases where you don't want to test, a few conditions. If there's some high winds coming, high winds have been shown to lower the air pressure in buildings by a lot. And in fact, they've been shown to lower the air pressure in buildings so much as to have an effect that they increase the radon concentration in the building by factors of 5 and 10. And I think maybe even more than that. We're going to see it in a slide coming up, that effect. So you don't want to do it when the weather is going to be bad. So you got to keep your eye open for thunderstorms, cold fronts, those kinds of things. And if you see there's a thunderstorm coming Tuesday or Wednesday, then you really don't want to deploy your detector on Monday. You'd like to avoid those as much as possible. Now, if during the week or prior to the week, you look at the weather coming for the week and it looks like a great week, and so you deploy your detectors on Monday, and then Thursday, there's a big storm comes through and you're picking them up on Friday, that's okay. You'll make a notation of that in your device placement logs, which we will see here. And that's all you can do. That's still going to be a good test. But if you know there's already a storm coming, then you should wait. And you should wait if there are any structural changes going on to a school building, because, of course, that will change dramatically all of the effects of the atmosphere in the rooms that you're testing. Quality assurance is a required activity in any scientific endeavor. That is, when we make measurements, we want to have some confidence that those measurements are good measurements. And there are just a couple of simple things to do in a testing program to underline good quality assurance. And they are, as you see here, duplicates, which we will do 10% of the time. And all we mean by duplicates is when you go into a room and you're going to deploy one detector, you're actually going to deploy a second one near it, about 4 to 8 inches apart as measured from their near edges. So that when these two values come back, they should be close to one another. And if they're not close to one another, there's something that should be done in that case. Now, we have an extra short video on quality assurance. The URL for it is given in the last slide. And if you want to know the details of how do you treat these, if they come far apart in value, you should take a look at that video. And then blanks, as I'm pointing out here, blanks you do 5% of the time. Now a blank, this is kind of interesting. In a blank, you get the kit, you get the detector, and you never unseal it. You leave it sealed all the time. And then you return it to the lab as if it had been deployed. I'll show you how to do that on the device log placement form, which is coming up shortly. Now, I'm going to review the entire planning of the program. There's a lot of planning involved. You have to think through everything that's going to happen prior to going and deploying all the detectors. Planning is very helpful. And we're going to look at this as if you were using short-term detectors. So there'll be the initial deployment, and there will be a set of follow-up measurements. And we will look at the protocols for that. If you're using a long-term detector, such as an alpha track, then there's no follow-ups involved, and you would omit that section. But here, we're going to look at the planning as if we were using short-term detectors, charcoal detectors fundamentally. Well, the first thing to do is to plan to do it in the cold season, if at all possible. That's going to work much better for you. Consider holidays. Make sure your deployment will not occur during Thanksgiving or Christmas or days where the teachers are in service and the students are not there. You want your deployment period of 2, 3, 4, 5 days to be while the students are there normally. And the next thing you're going to do is count the number of rooms you're going to deploy detectors into. We're going to consider just one building. Your school district may have a dozen buildings, but we're going to look at just one, and you would treat them all with the same kind of planning. All the buildings will be different, of course, but the planning will be very much the same. So we're going to next count the number of rooms, and that's not as easy as it sounds. It sounds like it ought to be easy, but it truly requires a bit of effort. And I've got here a floor plan from a school which was actually tested. And I'm going to give you an idea of how to do the counting. Now, I know you can't read all the little numbers in here, and you don't need to. For our purposes here, this is going to be fine. Now, to count up the number of rooms, you're going to you can start any way you want. I would start typically from the top left, work my way down, and all the way to the right. But you have some kind of system for yourself so you can count the number of rooms. So I would look at this room, and remember the question you have to answer is it frequently occupied, and is it in contact with the ground? Bearing in mind the two caveats that if there's a room under it, say a basement room that is not frequently occupied, but is in contact with the ground and is not going to be tested, then you would test this room even if it weren't in contact with the ground, if it's frequently occupied. Boy, that's a mouthful, isn't it? But for now, let's assume that outside of those caveats, this is the first floor, and they're all in contact with the ground. Let's make that presumption at this point. But remember, you got to check them all. So we look at this room and we say to ourselves, well, is it frequently occupied and in contact with the ground? Now, if it is frequently occupied, then we're going to deploy a detector in that room. And so what I do is I would put an X in that room, in that little space. And I would do that for all the rooms. Let's say this room I'm going to test because it's frequently occupied and in contact with the ground. I'd put an X on that space. And then when I'm done, I would count up all the X's, and that's almost the number of detectors I need. Remember, we need to have additional detectors for duplicates and blanks. But I'll go into that a little bit more. And then I would count up this room. Is this room in contact with the ground and frequently occupied? If it's a yes, I put an X in there. And I go through the entire floor plan that way. Now, even these little rooms, I'm going to pick out a couple of little rooms, say these two yellow ones here. Even these, I have to examine and see if they are frequently occupied and in contact with the ground. Are these frequently occupied and in contact with the ground? If they are, we need to put an X there. And you work your way through the entire floor plan. Here we're looking at what I believe is an auditorium, And there we ask, is it frequently occupied and in contact with the ground? If it is, then in this case, we have to decide how many detectors are we going to put out. Excuse me, if it's 5,000 square feet, then you would need 3 detectors. Remember, it's 1 detector for every 2,000 square feet. You need to put 3 detectors. And of course, as I said before, you don't put all 3 in one place. You spread them out, one in one area, another in another area, third in another, in a third area, so that you can sample all of the air throughout the room. And then you count up all the little spaces, putting an X in for every detector that you're going to deploy. So here in the auditorium, I would have put 3 X's. And then I count up all the X's. Now let's say that I get 100 X's. That means I need 100 detectors. Then I need 10% more for duplicates and 5% more for blanks. So I need 115 detectors. So in a case like this, I would really order about 120 detectors just to be on the safe side. So you see, the counting takes a little bit of effort. And when you're counting up the rooms, as I have done in a number of school buildings, counting up the number of rooms, I have to have somebody with me who knows if these rooms are in contact with the ground and frequently occupied. This is why the facilities people become so important. They really do know the buildings well. So whatever the numbers you have for the number of rooms that you're going to want to test, and we're assuming 100 rooms just because that's an easy number to work with, remember you need to add about 15%, as I'm putting the pointer here, for dupes and blanks. So you'll need about 115 in this example. And frankly, I would probably order a few more. If it were up to me, I'd probably order 120, just to have a few extras in case I change my mind about some of the rooms. You want to make sure that the device is approved by either the National Radon Safety Board or the National Radon Proficiency Program. They can be found on the net at nrsb.org or nrpp.org, and you can find your way to the devices, or you can simply ask the lab if they're approved by one of these 2 agencies. Make sure that the lab agrees to accept the device placement log forms that you're going to be sending them. Remember, without the 2 yellow columns, you're going to be sending those forms. Make sure they agree to that ahead of time. And then when the detectors arrive, make sure that you count them up, make sure that you get the right number of detectors, and read the directions for the use of those detectors carefully. The orientation of the detectors, the deployment time. Some of the detectors you can't use for more than 4 days. Pay attention to all of those questions. Pay attention to the issue of the orientation of the detector. Does it have to be horizontal? If you're going to be using it in some other orientation, you'll want to check that with the lab before proceeding. So there are a few things here that you really need to pay attention to in this part of the planning. Now, when you go to deploy the devices, I'm going to give you some hints here that will be very helpful to you. First of all, notify everybody who operates in the building. That's the students, the staff, the rest of the facilities people, the administrators, the secretaries. Let them all know that you're going to be deploying detectors Monday at 7 a.m. and they're going to be deployed till Friday at 3 p.m. Please do not tamper with the devices. They are perfectly safe. You're going to put a bunch of this information in there so that when you go to each classroom or each room to deploy your detector, you're not faced with an onslaught of questions. Hey, are these safe? What is that thing? Those kinds of questions you'll face in every room if you haven't sent a note out ahead of time. And it's just very time consuming. You're going to fill out the device placement log, which I'm about to show you, while you're deploying the devices. In other words, what you're going to do is you've got 115 devices with you, maybe 120, whatever you have with you. And you're probably going to put them in a rolling cart. And you should bring with you maybe some painter's tape, some paper clips, some things that will help you deploy the detectors. The reason you're going to bring these little bit of tools, pair of scissors, add that to it, is this, that in some cases, you may not find a really convenient place to put your detector horizontally. Now, in all cases, the little hole that you see here on top has to be deployed towards the atmosphere, towards the ear. You can't deploy it upside down. And when you go to make that deployment, you may not be able to deploy it horizontally. I'll leave this off here for a second. You may not be able to deploy it horizontally. You may be able to deploy it, say, on a chalk tray with the hole facing out. And in which case, you'll be deploying it vertically, which is fine to do. But that gives it the opportunity to fall over easily. And so to prevent that from falling over, you might want to just take some painter's tape, which I like because it doesn't mar most surfaces. Just put it across the front of the detector and on both sides. You can tape it to the wall, in effect, being careful never to block the openings where the radon's going to get absorbed by the charcoal. So have a few tools with you because that can be helpful. So if you're going to be deploying your detectors in an orientation that's different from what's prescribed in the directions, then be sure to contact the lab ahead of time, just a simple phone call, and confirm that that is okay with them, that they will still be able to analyze them. This can be an important concern. You're going to deploy all the detectors on the same day. You're going to be careful recording the dates and times when the detectors are opened. I'm going to talk a little bit more about this in a second. Duplicates should be 4 inches apart, and you're required to do some anti-tampering. Now, sometimes you'll deploy your detector, and remember, it's going to be out there for a few days. And when you deploy the detector, it might get tampered with. And it might be intentional tampering, might be unintentional tampering. But whatever the case, you'd really like to diminish that as much as possible. So one easy thing that you can do is you can take a sheet of paper, and all we've done here is taken a yellow sheet, and you can see what it says. And when you go to deploy your detector, and I recommend this with every detector you deploy, is you just put the detector on the sheet with the words facing outwards, so people will be able to see that this is a radon test in progress. Don't fool around with it, and that will be helpful. Certainly not a guarantee, but it is also certainly helpful. You're going to choose a location in each room and put this information on the device placement log, and you're going to identify those rooms to be used for duplicates and blanks with a D or B. I'm going to show you that here right now. Here's the device placement log, and you should make numerous copies for yourself. Now, this particular copy has room for only 1, 2, 3, 4 detectors, but when we've tested schools before, we've used device placement log sheets that may have room for 15 detectors. So it's not as if you need 25 of these, but make up enough so that you have plenty of space. I want to talk about this device placement log. This is very important. Record keeping is incredibly important in this testing program. You're going to identify the room in which you're putting the detector with a unique code for it. So this might be room number 100, and it's been 100 for 20 years, and it's going to be 100 for the next 20 years. So that's a good identifier for the room. You should not identify it with a remark like Mr. Jones' math class, because Mr. Jones might die this year, and next year it's going to be Mrs. Smith's culinary class. And you won't remember where Mr. Jones' class was. And you're going to keep these records for years. And so 5 years down the road, when you want to look at these records again, you need to have a unique identifier here. And then a location in the room. You walk in the room, you look for venting, exterior walls, doors, windows. We talked about these things. And you decide, okay, I'm going to put it on the south wall cabinet. So you're going to know where it is when you go to retrieve it a few days from now. Now, bear in mind, you're going to be deploying on the order of 100 detectors, or certainly many detectors. And if you're like me, the very next day, you won't remember where in each room you put those detectors. So I'm going to make a suggestion here to you. And that is, when you get to the room, it's room 100, take a picture of the room 100 so that the number 100 shows up. And then when you walk in the room and you deploy your detector, take a picture of where you've deployed the detector. Now, all of us have, almost all of us, I think, have phones that take pictures. So this is going to be really easy. It'll take only seconds. And then when you go to retrieve the detectors later, you can look at the pictures. Now, the first picture will say room 100. The next picture is the picture of the deployed detector in that room. And you just go along and you'll have all your pictures, and I think that can be pretty helpful. The serial number goes here. Every detector comes with its own unique serial number. When you deployed it and the time you deployed it. Within a few minutes, this would be good. Now notice there's nothing, no stop date, no stop time, because we haven't retrieved them yet. This is the deployment period. And the room temperature. The next room we did happened to be room 102. We put it on a bookshelf. Serial number, date, time, and again the temperature. Now here, I'm showing you what to do for duplicates. This D represents that we put a duplicate in the room above it, in room 102. And of course, we're going to put it in the same place, almost in the same place, remember 4 inches apart, and effectively the same place as the first one. And there's the serial number, date, and time, and temperature. Now here, I'm identifying this as a blank. And you want to put a B here. There's no location because you're not going to deploy this detector. You're just going to pretend it was deployed. And here's the serial number for it, and the start date and the start time. Now those you're actually fabricating. So you're going to take one of your detectors, and you're going to, if it's a can, you're going to get it. It looks like this, and you're never going to unseal it. You're going to leave it sealed up. And you're going to pretend that it was deployed. So when you collect all the other detectors later, you're going to return them to the lab. You're going to return this one to the lab as well. And the lab will not know that this was a blank, nor will it know that the previous one was a duplicate. Now you should spread out the duplicates and the blanks throughout the testing program. That is, if you're going to deploy 100 kits or test 100 rooms, then every 10th room, make it a duplicate measurement. And every 20th room, roughly, make it a blank. Now, the lab's not going to know that duplicates are blanks because you're going to be returning this device placement log to them when you've collected all the detectors and everything's ready to be shipped back. And when you go to send it back, first of all, you never send out your original forms. If they get lost or the lab loses them, they've got all the kits, but they don't have the forms now, you're going to need to make copies and get more copies over to them. Now, when this is completely finished, you'll see in a minute here, one fully completed. Before you make a copy of this, you're going to cover the 2 columns that are in yellow with another sheet. So when you make a copy of this page, everything to the right of the yellow columns, that is beginning with the serial number, that's to the right, that you will make copies of and send that back to the lab. So the lab will never know the room numbers, nor which are duplicates and which are blanks. Only you will know that. So then when you look at the duplicates later, you can tell if they're very close together that the lab's doing a good job. So the record keeping, incredibly important. When you go to deploy a detector in a room, plan on a few minutes in that room. You're not just going to be tossing these detectors in there and that's fine. You have to take a minute or two and be judicious about the choice of where you're going to put it. Now, I have found that a lot of the classrooms, at least, when you go from one classroom to the next, to the next, to the next, many of them are structured exactly the same. So if you find a good location in one room, chances are that location is going to work well for you in a lot of rooms. and the deployment will speed up a little bit as you go along in the process. Remember, there's a remark section in the device placement log form, and you should put anything in there such as unusual weather or unusual building conditions, etc., etc. When you go to retrieve the devices, again, you want to follow the detector instructions. You want to confirm that where the detector is when you retrieve it is in fact where you deployed it. Otherwise, there's been some tampering with it. You're going to check for damage. Is the can, if you're using cans, has the can been crushed? Has it been stepped on? And you're going to record the dates and times of the retrieval, and you're going to sign the log sheet. So the log sheet now looks like this. Notice now that I've got stop dates and stop times. And I made a simple remark here. Found moved to the south side shelf from the south wall cabinet. So I'm just putting a remark there for my own knowledge. And you'll notice the dates and times when it was stopped, that is resealed, are jotted down in here. Again, if you have your camera or your phone with a camera in it and you have pictures of where you deployed it, if you have a hard time finding your detector again, then you can refer to the photos. Now remember, you will have been placing this form out with it, so this too will help you find it when you go back to get the detector. Now, you're going to prepare the blanks. You're going to fill out the forms. Oh, let me just go back for a second. Notice here, the blanks, we even have a stop date and a stop time, which we've simply fabricated. And notice the times follow along. It's a few minutes after the duplicates were put out. Anyway, it's a few minutes after the previous detector was deployed. And you can see that here as well. So as far as the lab's concerned, what they're going to see is this information, and they're going to be able to analyze the detectors and come up with the radon concentration just from the information you see that's in white. They don't get the information that's in yellow. Okay. Once you've completed the log sheets, if you have a colleague that might be familiar with you or even helping you with the deployment, then make sure the colleague looks it over to make sure, did you fill out the form correctly? Are there any blanks? Did you leave out any information? Remember, the part of the log sheets that you're sending, the parts that you've made copies of, do not include those two yellow columns on the leftmost side of those sheets. Also, you have your 100 or so test kits ready to go. You're going to want to ship them back, of course, promptly, and you're not going to ship them back as individual packages. You're going to put them all in one box, and you're going to ship them all together. And you really need to do that, excuse me, within not more than 24 hours. And choose a shipping service that you know does not have significant delays in getting the detectors to where they need to go. Be careful about that. It might be worth spending a few extra dollars and shipping them with a way that you know gets them to the lab promptly. You're going to wait for your results, and it'll take about a week to 10 days to get the results back. And then you're going to perform the quality assurance calculations. And I mentioned here, take a look at the video reference below. We have that additional video on quality assurance. Tells you how to do the calculation. Not particularly difficult. If you're familiar with Excel, you can put the equations in Excel and it becomes actually a relatively trivial effort. But you can do that. And it's at that point when you do the calculations that you'll discover whether or not your quality assurance indicates the testing program was successfully done. And again, for more information on that, look at the video reference below. Now here I'm showing you what one school did when they did a bunch of measurements. And what they did was they had the floor plan And really the best floor plan to use is the fire exit plan, and that's what I was showing you earlier. They're on every door, and so it's easy to get copies of them. You might want to make the copies a little bigger to make it easier to read for yourself. But here's one where the data, when the values came back from the lab, was actually put on the floor plan. So you see there was a detector here and it came in at less than 0.4. And a lot of labs can't read down close to zero very well. And in fact, many labs will say, it may send a report back to you and it might read the concentration was less than 0.5, or in this case here, less than 0.4. And the reason they do that is when the value gets down to 0.5 or less, their confidence level, that's actually a statistical measure, their confidence level gets poor. And so they don't want to set, they don't know how much below 0.4 it is. They only know that it's less than 0.4, which is fine for us. That's a perfectly good room. And what I liked about this when I first ran into this some years ago was that you will never misplace the concentration with the room if the room identifier has been changed. So even if this room here is a gym right now, is turned into a library 5 years down the road, for example, you will know that the value in that space was 0.4. So this is a very nice mechanism. I like it a lot, and I encourage everybody to use this. Now, this also depicts another thing that I've mentioned, and that is, notice that the values in green, the fellow who did this put the values in green when they were less than 4, and when they were 4 or more, he put them in red. Except for this value here, which is actually an 8.4, but for some reason didn't come out to be in red. It should be in red. At this point then, you have the initial measurements in, and you've laid them out on your diagram, your floor plan, as we've seen. And in this particular example, there were 7 rooms that need to have a follow-up measurement made. So you're going to need 7 detectors, plus you're going to need 1 blank and 1 dupe. You must always do at least that. So you need a minimum of 9 detectors. I'd probably order 10. And you're going to deploy them under the same conditions. And I'm showing that here, same conditions. And by that I mean you're going to put them in the same shelf or chalk tray or wherever you put the initial ones. And you're going to do them at the same time. So if they were deployed, if those 7 rooms had detectors deployed Monday at 11 a.m., then you want to deploy these follow-ups at that time. And if the initial value detectors were retrieved Friday at 3 p.m., then you want to retrieve them Friday at 3 p.m. or as close as possible as you can to that. You're going to deploy them simultaneously, and of course I mentioned blanks and dupes again. Now, after the follow-up results are in, you're going to get 7 results back. Actually, you're going to get 9, right? You're going to get the 7, you're going to get 1 dupe and 1 blank. So after you get those 9 results in, then you're going to perform a QA review on that data. That's not a lot of data, but you're going to do a QA review on that. And to know the details of how to do a QA, take a look at the video that's at the very end, the very last slide of this video. And you're going to identify the rooms whose average values between their initial measurement and their follow-up measurement came out to be greater than or equal to 4. And those are the rooms you're going to strongly recommend that they need to be mitigated. You're going to create a report for the administration, and in writing that report, something you can refer to 5 years from now, and you will still understand what you wrote. You may want to get somebody to review it before you put it forward, just to catch any errors that you might have made in the writing of that report. Once you've accomplished all of this, you may have some questions. And if you do, as you see here on this slide, you should contact the Pennsylvania DEP Radon Division. Again, I want to say it again, that they are a very helpful group, and they will be happy to answer questions and give you some guidance. If you're interested in those free courses that I had mentioned earlier, you should contact the American Lung Association with the information given here. And they may also provide test kits if they have enough resources to do so. as they have done in the past. We've seen a few errors that I want to alert you to. One is the failure to seal detectors properly. And unfortunately, what we did see it is in these plastic trays. These plastic trays come in a plastic bag like this. And to deploy them, of course, you have to remove them from the plastic bag and deploy them. And then when you're done and you're retrieving them, they must be returned. They must be put into a sealing bag, which is this aluminized bag here, and it just slides into the bag after you've recorded all the proper information. You seal it. A little information goes on the envelope here, and seal it thoroughly, and then send them all back together. We've seen that error. We've seen the error where the deployment period was not 48 hours. I got to tell you, 48 hours is absolutely essential, or more. It's 48 hours up to typically the maximum deployment period of these charcoal devices, which is 4 days, 5 days, something on that order. You're going to read the directions and identify what exactly the number of days is. And then once you've collected them, don't delay in sending them back to the lab. It's going to take a couple days in shipping probably. And remember that the radon is decaying in the detectors. The lab do take into account the transit time. They can do calculations that correct for that. But if the transit time's fairly long, then they won't be able to come up with a result that's has any confidence in it at all. So be careful about sending them back right away. Thank you.